Good afternoon, everyone. This is Mr. Baldwin again. We're going through balancing chemical equations. Now, whether you're taking an AP class or whether you're in honors or regular chemistry, this process is going to be the same. So you want to make sure that you pay attention and that you refer back to this on a regular basis. Now, what is a chemical equation? First off, representation of a chemical reaction. I think that part is very straightforward. It basically shows you what's going to happen for the overall reaction. What's on the left side of the equation, or the arrow, is going to be your reactants. What's on the right side are going to be your products. Reactants produce products. Always makes sense. Now, an example of what we're going to be looking at is, this is a simple synthesis equation. Carbon plus oxygen gas is going to yield carbon dioxide. Which side would be the reactants? I think you guys can get this part. Now, of course, we're looking again and saying that this side is going to be our reactants, while these are going to be our products. Products are going to be very important to pay attention to, especially as we look at stoichiometry. Now, reminders about formulas. When we look at an overall formula for a compound, remember we're going to have these subscripts. Those subscripts tell us what or how many moles of that atom we're dealing with within the compound. As we look at this, using the same information, if I have CO2, that means I have one carbon atom with two oxygen atoms, or 1 mole of carbon to 2 moles of oxygen. Very straightforward. When we look at balancing equations, we're not going to make any changes to this portion of it. So I want that to be very clear as we continue going. I'm going to say that a little bit later too. Now, coefficients. If you think back to your math class, think back to your algebra. Whenever there's a quantity given, say you're given something like, let's see, 2 times the quantity x plus 1. We usually call this number right here the coefficient. It's going to be the same thing that we're going to deal with in a chemical reaction, except the coefficient is going to tell us how many moles overall of that compound we're dealing with. You notice I'm using the term moles a lot. It's just, again, pointing out how many of them we're dealing with in terms of the overall reaction. So if I write 2 CO2, this tells me that there are 2 moles of carbon dioxide, or 2 CO2 compounds or molecules present. Now, taking a step back, remember our law of conservation of mass. I told you we'd come back to it throughout the year. Basically says that matter cannot be created or destroyed in a chemical reaction. Just gets rearranged, just looks a little bit different. This is what we're going to do as we look at balancing the equations. This is the reason why we have to balance the equation. If I start off with 2 molecules of carbon dioxide, that means I'll have 2 carbon. I have to, at the end, make sure that I still have those 2 carbon. If not, then I have to figure out how this whole thing balances out to make this law true, because we cannot negate or get away from this idea. So, if the number of atoms is the same before and after the reaction, it's a balanced equation. If we go back to our original, carbon plus O2 yields CO2, everything is balanced. I have 1 carbon on each side, 2 oxygen both sides. If it's not balanced, we have to make sure it makes sense. We have to get it working according to our law of conservation of mass. So, how do we go about doing this? Now, with balancing the equations, what I want you to notice is we're not going to change the subscripts. We will not change subscripts. No changing subscripts. Make that clear. What we're going to do is we're actually going to put the coefficient out front, and that'll help us to be able to balance the overall portion. Now, this means that if I have to add to either side, I have to add the entire compound. I can't just add a portion of it. Now, how will we balance the following? If I have nitrogen oxide, or nitrogen monoxide, yields nitrogen, dinitrogen monoxide and nitrogen dioxide, I have to figure out a way to balance this whole thing out. Make sure I have the same number of nitrogen on both sides and the same number of oxygen. And this looks like it will be very difficult, but we're just going to follow a couple of steps. First, we're going to deal with, and this didn't come out the way it looked at it. We're going to balance one element at a time. We're going to treat the polyatomics as if they are 1 unit. So if we have polyatomic on both sides of the equation, we want to make sure we balance that part out first. Our second priority after polyatomics is we're going to metals. Then nonmetals, hydrogen, and oxygen. A lot of people will try to go with oxygen first or even hydrogen first. And in that case, that many times will make your work so much harder. So we always leave those two for last, oxygen especially, because if we work out the others, sometimes the oxygen falls right into place along with it. Now, what you want to remember to get this priority in your mind is penguins may not have oxygen. Now, we're not being mean to penguins. We love penguins. We know they're nice aquatic animals, all that good stuff. But this is just a way for us to remember what gets priority, what do we start with, and how do we finish it. Now, after we've gone through, if we unbalance an element, when we're going through to say, start with our polyatomics, we're going to leave it because we'll work back to it. We go through one way, and then we come back around to the beginning. Sometimes you may have to do this a couple times. Sometimes it'll work itself out within one time. But we're going to use a little bit of our math, our multiplication, division, addition, subtraction, to be able to work to balance these out. Now, after working through the equation the first way, we want to look back at the overall thing and see, are we balanced or do I need to start going back through again? Repeat steps 1 through 3, until all elements are balanced. Now, let's get some practice in here. If I have aluminum oxide plus carbon yields aluminum plus carbon dioxide, how will I go ahead and balance this out? According to my priority, we said that we'll start with, I'll write it here. Penguins may not have, have oxygen. So, penguins or polyatomics. Do we have any polyatomics here? No, we don't. So, that means we can go ahead and cross that out. Polyatomics are gone. All right, now on to our metals. We have aluminum on both sides. On my left side of the equation right now, I have 2 aluminum. On the right side, I only have 1. So what I'm going to do to balance that out is I'm just going to go ahead and write, for right now, aluminum right here underneath. This keeps me from having to go back and erase and rewrite and erase. So now, next thing, since metals are taken care of, says now we're going to go to nonmetals. Our nonmetals in this case are oxygen and carbon, but we know that we said we save oxygen for last, so we'll come back to that one. So we have carbon. I have 1 carbon on my left side, 1 carbon on my right side, so that one's okay. No hydrogens to deal with, and oxygen comes next. I have 3 on the left and 2 on the right. Now, looking at this information, there's no way that I can get 3 to equal 2. So I want to look and see what is the least common multiple that we can deal with in this case between 3 and 2, and that's going to be 6. So I need to make sure I can get 6 oxygen both sides. How do I do that? Well, if I have 3 oxygen on my left, that means I can multiply it by 2 to get 6. So now I'm dealing with, oops, my marker won't let me go further, Al2O3. That'll give me 6 oxygen on this side. And if I come all the way over to my right, that means I need to do 3 times 2. CO2, CO2. That gives me 6 oxygen on this side. All right. Now, my equation seems like it got even worse. So let's go ahead and solve and finish the rest. So since I've worked my way all the way through, let's go back to the beginning of our equation. Now I have 4 aluminum on my left and only 2 on the right. So I'm going to add 2 more aluminum. Okay, now next, back to our nonmetals. I have 1 carbon on the left and 3 on the right. So I'll remedy that by adding 2 more carbon. And no hydrogen still, oxygen, I have 6 and 6. Everything is balanced. So now I just need to write my coefficients. So, and again, my marker won't allow me to go further over, but if it would, my final balanced equation would be 2 aluminum oxide. And I know this by how many times I've written it down. So, plus 3 moles of carbon yields 4 moles of aluminum plus 3 moles of carbon dioxide, CO2. This will be my balanced equation I'm going to start working with. It follows, according to everything, my law of conservation of matter. And when I do a reaction, I can actually use this as my recipe, my measurements, and my actual substances to be able to go ahead to complete the overall problem or process. So what I want you all to do is go ahead and look in your textbook, work on sample problems given to you, on page 131. Working on page 131. Go ahead and look at those sample problems. I'm going to put up more videos, so don't worry, of working through different types of equations so we can start to sort of get the idea of what we're going on with. Have a great afternoon. I look forward to seeing you in class, and